It is our constant source of light and heat, and it's essential to a sustainable energy future. The National Renewable Energy Laboratory in Golden, Colorado is a global leader in developing cost-effective solar electricity.
I think the future of solar is very promising.
NREL's team is the power behind internationally recognized advancements in photovoltaics technology.
Successes depend upon the talents and the abilities and the innovation, of the scientists and the engineers in this organization.
Everything came together. I mean, the stars, the heavens, all of it.
This is the birthplace of the world's most efficient solar cell.
This is the laboratory where we make the devices that are over 40% efficient.
NREL scientists invented the multi-junction solar cell.
You'll see it go alternate between the indium and the gallium.
Individual layers of atoms are precisely placed on a tiny wafer.
This is what we call a gallium arsenide substrate.
Put this device in the sun and it produces electricity. Multi-junction cells now power nearly all space satellites and the Mars exploration rovers.
If it'll work on Mars, we can make it work anywhere.
The challenge is making it practical for use on our planet. This cell costs a lot to create, but add an inexpensive lens to concentrate the sunlight, and the efficiency levels skyrocket.
40% of the sun's energy is being converted into useful electricity.
I love being part of this technology.
NREL is also a pioneer in the thin-film photovoltaic field. Extremely thin layers of semiconducting materials are deposited on the support structure.
And that support we call the substrate.
This technology is much newer than the more common silicon cells, but it also promises to be more cost competitive because thin films require less of the light-absorbing materials to generate electricity.
That's where we grow the heart of the solar cell.
Thin film efficiencies are close to 20% in the laboratory.
This is a remarkable efficiency, by the way, for polycrystalline thin film material, or for this class of materials.
Solar cells are used outdoors, and the element's durability is a must.
We want these solar cells to last for a long time, 20 years or more.
Many of the manufacturers are now looking to thin films to try to decrease the cost of making the modules.
Industry partners send their photovoltaic systems to NREL.
Welcome to the outdoor test facility.
To see how they endure rain, snow, hail, dust, and the passing of time.
Their output is decreasing by about 1% per year.
Some of the modules monitored here date back decades. Others are newer developments. NREL's solar array field is striking to see.
This is about 1,100 watts of array right here in front of me.
It's one of just a handful of test facilities like it in the world, a place where engineers analyze photovoltaic products from solar streetlights to shingles.
These are a couple of examples of roofing products.
To make sure they perform.
If you had an energy efficient home, you'd need probably 2 to 4 times this size array in order to offset your entire electrical needs.
We look at all sizes, shapes, technologies, you name it, we've measured it.
When you're talking record-breaking solar cells, accuracy is everything.
The first thing we do is we measure the area.
NREL's Performance Characterization Lab verifies photovoltaic efficiencies.
The efficiency is defined as the maximum power.
It also looks for imperfections.
The shutter just opened up, and you can see a probe making contact to the cell.
This is a certified calibration lab where researchers and manufacturers submit their solar cells for evaluation.
We do approximately 100 of these a month.
Various lamps and different colors of light imitate the sun's rays.
This is our solar simulator.
So scientists can study the sample's responses to the solar spectrum.
They're just trying to make it cheaper and better.
I'm Steve Robbins, and you're here at the Process Development Integration Lab.
The PDIL in the Science and Technology Facility is NREL's latest tool to advance the science of photovoltaics.
Oh, I love it. This is a fantastic facility.
The technology here allows scientists to deposit layers of a solar cell, do their research, without exposing the sample to air.
The ability for us to move this 6-inch sample from machine to machine and completely under vacuum is actually unique in the world. You will not find anything else like this anywhere else.
A robot in the center of this steel chamber shuffles the samples through the various steps. The vacuum pod is vital to this process.
Here, we're actually trying to protect from molecular level contamination.
The pristine environment is critical because an entire photovoltaic stack can be just a micron or two.
A human hair is roughly 80 microns.
Gases can react with the surface. Even a speck of dust can contaminate a sample. Manufacturers are taking advantage of the PDIL to improve their solar cells.
Many scientists, they see it and they're just awed, they're amazed, they're like, oh, we need that.
How many times during my career here at NREL have I heard that won't work? It won't happen.
Overcoming obstacles, pushing new horizons, NREL's Center for Photovoltaics is rising to meet the next challenge, to make the cost of solar energy competitive with other electricity sources by the year 2015.
It's going to be more than competitive.
Capturing the light from the sun, converting it to low-cost electricity.
Now we're working on 4-junction solar cells with efficiencies that could go as high as 50%.
The next generation of solar power is dawning at NREL.
These are all technologies that are revolutionary technologies. These are things that are beyond what people could even think.